Hello, this is section 3.4 in our textbook, which is all about proving that lines are parallel or deciding if they're parallel based on a picture. Okay, so let's do a few together. You can finish the rest later on your own. Question number 1, are these lines parallel? Why or why not? So first identify the angles that they are giving you. They're both 93 degrees, so they're the same. And then you need to say, well, what types of angles are those in the diagram? Because they're in the same position, that means that they're corresponding, and then we would say if the corresponding angles are the same, then those lines would be parallel. A similar idea comes into play for number 2. So I notice these are both 81 degrees. That means they're the same, so I could put my little tick or arc marks. And then I say, well, what types of angles are those? They're both on the exterior, but they're on alternating sides of the transversal, so they're alternating exterior angles. So if alternate exterior angles are congruent, then that means the lines are indeed parallel. So your if-then statements are going to look something like this. Whereas before we were always writing if lines are parallel, then blah, blah, blah. Now we don't know if the lines are parallel, so that comes last. That's our conclusion. Okay? So now let's try angles 3 and 4. Well, angle 3 is a little different because both of these angles are on the interior of lines A and B. And they're on the same side of the transversal, so they are consecutive interior angles. What do we know about consecutive interior angles if the lines are parallel? We know that they would add to 180. So let's check. So 120 plus 55, that gives me 175 degrees, which is not 180. So no, these lines are not parallel because the consecutive interior angles are not supplementary. Doesn't work. Okay, example number 4 is a special one because we got two angles that are 40 degrees, so they're the same. They're also vertical angles. Is that going to help me decide if A and B are parallel? Well, not really, because I don't know any of these angles. They're all missing. So anytime you have vertical angles, that's not enough info. They could be parallel, they could not be parallel. We just don't know because all we have is vertical angles. So you just say not enough info. Questions 5 through 8 on your homework are really similar to this, so you can go ahead and pause the video and see if you can complete the rest of those on your own. Okay, on the back of the worksheet, it asks you to find the value of x that makes line P parallel to line M. So in all of these examples, we've got two lines P and M that we want to be parallel. Well, I'm going to jump right to question number 12 because I think that you could do the others on your own. 12 is a little weird looking because this angle's on the exterior, this angle's on the interior. What the heck's going on? So when this happens, you need to see if you can figure out what other angles would be the same as the given ones, kind of like we do in a proof. So you get a little game plan. Well, I'd notice this angle, the 2x plus 10, is a vertical angle to this. So these are the same. And then I also notice x plus 8, I'm going to mark that in here, 2x plus 10, because it's the same. Okay. I also notice that x plus 8 is on the interior and the same side of the transversal as this 2x plus 10 I just filled in. That means that they are supplementary. If two angles are supplementary, that means they have to add up to 180. So I'm going to set up an equation now. 2x plus 10 plus x plus 8 equals 180 degrees. Then I can go through and solve using regular algebra to get my value for x. So I'm going to combine my like terms, then subtract, then divide. And that will give me my value for x. And x would be equal to 54. You could always check this if you wanted to by taking this value and plugging it back into these angles wherever you see an x to really make sure that they actually do add up to 180. Okay? The other examples here, they might be supplementary or they might be the same depending on the angle relationship. So again, you need to just kind of brainstorm your way through those problems. Okay, now I'm going to jump to question number 14, which is a formal geometric proof that asks you to prove that lines are parallel. We haven't done a lot of these yet. Okay, so first we're going to always start with the given and see if you can develop a game plan. We know 5 and 2 are supplementary. Well, do they have any special relationship? Not really, because this one's on the exterior, this one's on the interior. That's not a special angle relationship. So then we get some ideas going. Well, 5 has a vertical angle. I'll name that one. I'll name it angle 1. So 5 and 1 are vertical. That means they're the same. Then I can see 1 and 2 should be supplementary. Well, that makes sense because 5 and 2 are supplementary. 5 and 1 are the same. So if I could show that 2 and 1 are supplementary, then I can say, well, these lines have to be parallel then. So my game plan is good to go. Now I'm going to go to my proof and start with the given. The first thing that I said was I created a new angle, angle 1. So now I could say angle 5 is congruent to angle 1 because vertical angles are congruent. And now I'm going to basically substitute, just like I did in all those other examples. I'm going to take this angle 1. Where could I plug it in? I could plug it in for this angle 5 right here. So now I could say angle 1 and angle 2 are supplementary by substituting. Well, those are consecutive interior angles, so if they're supplementary, then the lines have to be parallel. So now I can make my conclusion P is parallel to Q, because if consecutive interior angles are supplementary, then the lines are parallel. And then I'm done. I've proven that P is parallel to Q. Thanks for watching. I hope this helped you out.